Good morning everybody. Myself Dr. Diwakar Tichunarkar. I am a senior lecturer of this college, Praveen Patil College of Diploma Engineering and Technology. Mahavidyalay Marg, Bhayandar East District, Thane. Today I explain or start experiment number 13. This is Joule constant. This experiment we have to perform. So aim or title of this experiment, determine the Joule constant by calorimeter. Here calorimeter is name of instrument. So those instrument we have to use in this experiment or resource or apparatus, that is power supply, ammeter, voltmeter, rheostat, tap key, resistance wire, etc. And formula for this experiment we have to use J equal to W upon H. Here J is the Joule constant or mechanical equivalent. W is work done and H be the amount of heat. Then procedure of this experiment, record the least count and range of the ammeter, voltmeter and thermometer. Weight the calorimeter. Take the water in calorimeter and weight it again. Connect the circuit as shown in circuit diagram. Supply the current in the circuit. Adjust the current to desired value, say 1.5 ampere using rheostat. So student, the function or use of the rheostat to increase or decrease the current by using rheostat. Note down the corresponding voltage as per time by using stopwatch. Note the temperature theta2 and initial temperature of water when we will take in the calorimeter, that is theta1, and after increasing temperature, that is theta2, keeping your mind. So student, this is the circuit diagram. Suppose this is the calorimeter. This calorimeter is copper pot, keeping your mind. So this is also known as calorimeter. Then in the calorimeter we will take some water. First we weigh the calorimeter. After that, when we take the water in the calorimeter, again take weight with calorimeter plus water. Then this calorimeter fixed in the box. This box is wooden box and this is the wool legging. This is the legging. Then connect the circuit diagram as shown in connect the circuit as shown in circuit diagram. In this calorimeter experiment we have to use thermometer. The range of the thermometer is 0 to 1110 degrees Celsius, keeping your mind. So this is the battery or power supply. Here is tap key connected to the power supply of the positive terminal. Then negative terminal of the battery or power supply connected to the rheostat, and this rheostat, variable of the rheostat connected to the ampere A, and this ampere, second terminal of the ampere connected to the coil or stirrer. This is the stirrer and this stirrer is used in the calorimeter, so stirring the water throughout the experiment. And this is the thermometer we have to use. When we start the experiment, temperature increases at that time to measure the temperature of the water at time to time. Then calculate work done W. We will take, this is the observation. In the observation table we will take first least count of the ammeter, that is 0.01. This is the instrument. So 0.01 ampere, range of ammeter is 0 to 100 ampere, Least count of voltmeter 0.1 volt. Range of voltmeter 0 to 25 volt. Mass of copper calorimeter MC, mass MC calorimeter. So that is we have to consider 30 gram weight of this pot calorimeter, that is equal to 0.03 kg. Mass of water in copper calorimeter plus water, this is I can write directly 0.045 kg. Then specific heat of copper calorimeter, that is 0.1 kilocalorie kg per kg degree Celsius. Then specific heat of water, that is symbolically SW01 or 1 kilocalorie per kg degree Celsius. And least count of thermometer minus 10 degrees Celsius, keeping your mind. This all value we have to write and to check the physically by using the different type of instrument. After that, initial temperature of water, suppose this is the water in the calorimeter. So when we have to measure the temperature of water, that is theta 1, so we have to consider 24 degrees Celsius because today is cold and therefore the temperature of water is very less, like at 24 degrees Celsius. Then current flowing in the circuit 6 ampere and voltage developed means voltage produced, that is 4 volt, and this is the observation table. Here is when we have to start the circuit and current flowing through the circuit at that time to increase the temperature. So up to 300 seconds, that is 5 minutes, up to 5 minutes we will take, after 5 minutes we will take reading. So at that time theta 2, matlab increasing temperature of the water 29 degree, and this value we have to put in this equation, W equal to VIT, Vb the volt, that is 4 volt, then I 6 ampere and T 300 seconds, so we get 7200. Then this yet amount of heat we have to calculate, MC mass of calorimeter, SC specific heat of calorimeter plus mass of water and specific heat of water into theta 2 minus theta 1, so we get this value 0.244. This value you can write in the power form, that is 2 into 10 to the power minus 1, 10 to the power minus 1, keeping your mind. So all values here is 2.4 into 10 to the power minus 3. Here is 2.880 into 10 to the power minus 3. Here is also 3.840 into 10 to the power minus 3. Here is 4.320 into 10 to the power minus 3. This value we can write in the power form. Also this value constant W upon H. W, this value is W, and H, this value. Student, this value of H and find the value of J, that is mechanical equivalent or Joule constant. So this value. This W divided by H, so we get this, W divided by H, we get this, and up to we will take 4 readings compulsory, 4 to 5 readings. So this value we can write again power form, keeping your mind, but in observation table or in the PPT here is not coming the power form, and therefore I can write only this type of value. But this value 3 into 10 to the power 4, this value 5 into 10 to the power 4, 5.625 into 10 to the power 4, and this 6.666 into 10 to the power 4. This type of power form we can write. Then our result it means that this all values we have to take mean reading, and this 30,000, 50,000, 56 and 66 adding to each other and divided by 4. So we get answer 50728 joule per kilocalorie, or this value we can write in the power form in this way. Then value of J by graph 7500 J per kilocalorie and equal to 7 into 10 to the power 4 joule kilocalorie, keeping your mind. So this value I can write this type by using the graph. So difference between two values, graph and experimental value. This is 5 into 10 to the power 4 and 7 into 10 to the power 4. So student, this type of reading we will take by using the experimental process. Process is very simple. First, this is calorimeter. This is the wooden box. This is lid on the wooden box, that is cover, you may say like that. This is the cotton. This is the cotton and this is calorimeter. So calorimeter fixed in the box, and in the box, in the calorimeter we will take some water, and in the water kept the stirrer. The use of stirrer is to stirring throughout the experiment and note the temperature in a particular time. So student, this is the coil, and this coil, here is two terminal of the coil. One terminal is connected to the tap key and second terminal connected to the ampere, and ampere's next terminal connected to the rheostat. This is the symbol for rheostat, and rheostat is variable of the rheostat connected to the negative terminal of the battery or power supply, and positive terminal of the power supply connected to the next terminal of the tap key, keeping your mind. So this is the simple construction or simple connection of the circuit. So any problem, any doubt, and you ask me any doubt, any problem, but we will take precaution. So precaution, already you have to know precaution. We connect the circuit diagram or circuit as shown in circuit diagram, where we have to connect the circuit as shown in circuit diagram tightly. So connection should be tight. Connection tight होना चाहिए. Weigh the calorimeter and water accurately or properly. Stir continuously in water in calorimeter throughout the experiment. Experiment होने तक अपने को स्टरर कंटिन्यू स्टेरिंग करना पड़ेगा वाटर में, और कैलोरीमीटर और वाटर का एक्यूरेट वेट लेना पड़ेगा. और जब सर्किट डायग्राम में कनेक्शन करते हैं एज शोन इन सर्किट डायग्राम, सो कनेक्शन शुड बी टाइट होना चाहिए. एक बार फिर से चेक करना चाहिए. सो यदि कनेक्शन लूज रहेगा तो आप लोगों को प्रॉब्लम आएगा, रीडिंग नहीं शो होगा बेटा. तो ये आपको देखना है. अभी ऑल रीडिंग वी हैव टू कंसिडर इन दिस एक्सपेरिमेंट. सो दिस टाइप ऑफ रीडिंग occurs in the experiment when we have to perform in the lab, keeping your mind. So today I stop here, student. Thank you very much.